website. But now we want to focus in a little bit more on machine learning, which is obviously a crucial aspect of AI. And we're going to share some very practical tips and some advice and some pointers on how to bring machine learning into workflows, how to get started, some case studies from media organizations that are using machine learning, a bit of theory, and some practical tips. So I'd like to welcome our expert for the next 30 minutes, Will Fletcher, who's a machine learning researcher at Datatonic. So make him feel welcome, and please share what you're learning about machine learning on social media. The hashtag is BVE19, and if you're good and Will's feeling generous, he'll answer your questions as well at the end of the session, so the roving mic will be doing its rounds. So Will, over to you.
Thank you very much, Rob. And thank you all for turning out at the end of the day. Hopefully you'll be rewarded with a little bit of fun. It's somewhat lighter than previous presentations, I hope. And the idea here is to give you an overview of machine learning. So my job title is machine learning researcher at Datatonic. And what I spend my time doing is looking at business problems and trying to work out how machine learning fits into them. This is going to be half an hour of the reverse. It's going to be my job upside down. It'll be looking at machine learning as a whole and trying to work out what business problems can be solved with it. So hopefully you'll see what I mean as we progress. And I want to do this for two main reasons. One is to get you comfortable with machine learning, maybe a bit more of an appreciation for what it actually is. And of course, the other is to hopefully benefit from it. Plan out how you can bring machine learning into your work. I want to start with data. Data is always a good place to start. This is Google search data over the last 15 years for two search terms. We've got machine learning in blue and big data in red. And the first thing I want to point out from here is obviously on the far end of that. That's recent history. Everyone's talking about machine learning. It's not a bombshell of a point, but that is when machine learning is being talked about, is right now. The next thing is, why is machine learning being talked about right now? Because actually, it's interesting at this end that machine learning was still being talked about 15 years ago, before it was in the news, before you'd had all these DeepMind breakthroughs, before you'd had image recognition. Machine learning, essentially, is a field of computer science that goes back well into the 50s. So why is it only now that machine learning is being brought into industry and talked about with such the hype that it is today? Well, one part of that reason is computational power. That's allowed us to do machine learning much quicker, allowed us access to techniques that would have been prohibitively expensive beforehand. But the other aspect is this red curve. We're fortunate as machine learning practitioners to have followed a trend of companies becoming comfortable with data, becoming comfortable with its value, becoming comfortable with collecting it at large scale. And that really has enabled machine learning to flourish in the last 5-10 years. So if everyone's talking about machine learning and wanting to bring it in, then what's the question that machine learning solves? If you've been paying attention to the news about machine learning, you'll know that machines can now play Go better than humans. They can recognize objects, cats, in images. And they can make these sort of trippy Mona Lisa things. So looking at these tasks, they're all very different. And you might get the impression that machines can do anything. Or maybe they can only do these things. So to answer what machine learning can help you with, we first need to unpack a bit what machine learning is. So whatever you know about machine learning already, I want you to concentrate on thinking of it like this. It's a machine that learns. So this is the machine. It brings in data at the top, that's your input, does something to it, there's a function in the middle, and your output is knowledge that you can work with. It's knowledge that's valuable to you. So that's the machine, and this is the learning. The learning process, regardless of what machine learning algorithm you choose, is based on this training loop process. So the more data you put in at the top, you go around this training loop, and the machine gets better at converting that data into knowledge. Oh, apologies for the cropping on that. If you go out and try to do machine learning yourself, you're going to run into these sorts of problems. It's going to be overwhelming. You're going to want to give up. Apart from anything, over on the very far right, you've got how do you prepare your data in such a way that the machine can learn from it? And then at the end, how do you make sure that you can get value out of the knowledge you've obtained? All the other stuff is very technical and difficult. So generally speaking, if you want to do machine learning, you're going to find it a tough time. It's hard because you need to be simultaneously a mathematician, a scientist, and a programmer to get it working properly. We've already discussed it costs a lot of compute power. So we're not talking quick turnaround here. And if you shove a lot of computational power in there, your bills are going to go up. Even if you get things on track and learn something, it might not be a valuable thing. It might be completely the wrong thing. And the other thing to watch out for is that the future might not behave like the past. You might not have a model that generalizes well. So where do you start? Hopefully I've terrified you a little bit. If you go out onto the internet and ask how to get started with machine learning, you'll run into an awful lot of tutorials that start with maths. They'll start with a neural network and what's going on inside it, and maybe some toy data that doesn't really tell you how to use it for your problems. It doesn't really tell you the overview, the landscape. So hopefully that's what I'm going to do right now. And my secret for you to share with you today is that there's only 3 things that machine learning can do. So if you can think about your problem in one of these 3 ways, then you know how to start. So we're talking about the output of the machine learning model. We can't do anything about the input. The inputs are data. We don't have control over that. But we do have control over the output. We can make our output do one of 3 things. We can make it predict something. So if we have some target data, if we have a target that we want that output to resemble, we can train our model to fit that target as close as possible so that we can use the model in future to predict that target when we don't know the target. We could instead make the output closely resemble, approximate, and compress the input into a useful form. I'll talk more about these in a bit. And the third thing you could do with your output is if it's a number, you could simply say, make the number bigger, make the score go up. So those are the 3 things that if you can think about your problem in terms of one of them, you know where to start. And these problems are commonly referred to in machine learning as supervised learning, unsupervised learning, and optimization. In other words, we're talking about a machine that makes a guess from being educated on past data. So that could be like a spam filter. You're talking, is this email spam or not? The only way you know is from telling it on previous examples, that one is spam, that one is not. With unsupervised learning, we're talking about generally obtaining meaning or understanding from the variation you can see in your data. So that could be looking at a social network graph. You're analyzing it to find different communities in there, or which are the important people. And then on the optimization side, as I said, you're just looking to make a score go as good as possible. So that would be maybe a key performance indicator like revenue, or it could be latency. If you're serving a website, you want to get that as low as possible. What I'm going to do now is walk through each of these three, specifically in relation to media problems. So firstly, prediction problems in media. The way to think about this is, what sort of data do you have? To start off with, it's fairly general. I'm going to talk about two types of data. You've got data about your users, and you've got the content you're serving to them, the content itself. And what predictions can you make from those data? Well, about your users, you might want to be able to understand their behavior. So we're talking about, do they enjoy the content you're serving to them? Will they pay for it? Will they share it? Or will they just leave? And hopefully once you've predicted that, you can make some sort of action that leverages that knowledge. About your content, you could make predictions that are some form of metadata. So this could be something very familiar to everyone, just adding subtitles from speech. So you run a machine learning model, get speech to text, and live subtitles appear. Or it could be equivalently dubbing from one language to another. These are both tasks machine learning is quite good at these days. Alternatively, you could provide tags. So what topic is the content about? Or highlights. So summarizing, say, an article into a few paragraphs to get the overall gist of it. Or editing a piece of film down to maybe a 5-minute trailer. And then the interesting one at the bottom here, I've put this, is identifying claims so that you can fact check them. There's a fantastic charity in the UK called Full Fact, who will use this automated machine learning approach to identify when a claim is being made, say in an article or in a political speech, so that a human can then go and fact check it. And this obviously saves a lot of time in terms of the human hasn't got to read as much. And you can maybe think about automating the fact-checking process after that as well. So that's a flavor of what you can predict with media-related data. A self-description problem in media. We're talking about using that same data, so data about your users or the content itself, and building some sort of useful representation that encodes maybe the similarity between how your users behave. So you can begin to identify different audiences. Or on the content side, you're looking at the similarity between content. So you've sort of established what genres there are, what different types of content you're serving. And in terms of optimization, this is usually in terms of you've got variants of either your content or how you distribute it or how you're pricing it. And you're trying to optimize a metric. And as we said before, this would be a key performance indicator, something along the lines of how many people are seeing it, how many people like it, or how much money you're making or saving through that action. So that's the overview of what sort of media problems might exist within a framework of machine learning. And get into the habit of thinking, with the data I have, can I identify a problem that fits into one of those three? I'm going to spend a bit of time now going a little bit more detail. I promise there's no maths, but it's just a bit of technical exploration of how a machine learns. We're going to solve this problem. It's a toy problem. This isn't particularly media-y. We're going to find what's the best recipe for lemonade. And when I say lemonade, I want you to think, for example, soliciting donations on a website. So how are you best going to go about soliciting donations? So we're going to start with some definitions. What do we mean by best in terms of lemonade? What's going to go into our lemonade? And what are the parameters that our machine is going to learn in the process? So the best lemonade is the one that gets, I'm saying, the most compliments when you take it to your garden party. And in the in the soliciting donations example, this would be simply how much money you get given. The inputs for the lemonade example are obviously lemon, sugar, and water, if you're being conventional. And again, in the asking for donations setup, your input is that at some point you're going to display a banner saying, please give us money. The parameters you're optimizing over, within the lemonade example, we're talking what concentration of lemon and what concentration of sugar. So they are actual numbers. We're not going to go further into the maths, they're just numbers. And so the numbers you might talk about in terms of optimizing a donation request would be how much you're asking for, and when you're asking for it, and where you're asking for it, all in terms of numbers. So that's the setup. What's the model? i.e., what is the output and how do we get there? Well, we already said the output is going to be observing how many compliments we're going to get at the garden party. So how this works is, first we've got to make our lemonade. So we use the inputs, lemon, sugar, and water. We use the parameters, which are the concentrations of the lemon, the sugar, and the water, and we make our lemonade. Then we take the lemonade to the palace, to the garden party, and see how many compliments we get in return. So that's our model. And what we're going to do is, every time we go forward through that model, we're going to measure how many compliments we get. So with this experiment, we take the lemonade to the garden party, and we get something like 60 compliments. So it's okay lemonade. But can we do better? Well, we try again. That didn't work so well. That's, no one's complimented that. It's just water. We try again, and that's the setup we're going to do. This is what we're going to do in two different ways that I'll explain in a moment. But the aim is to find the best lemonade. So how do we train this machine learning model to get to the best lemonade as quickly as possible? Well, without machine learning, you'd be talking something like a grid search. You could do a random search. There's a whole bunch of different searches that are not machine learning. And this is how it would work. You'd do an experiment for every possible combination that you want to trial and see which ones perform best. And indeed, we have found a good candidate lemonade up in the top right-hand corner. But in order to get there, it's taken a lot of trials, and most of the trials were either disgusting or at the very least not informative. We already knew, for example, it was going to be good up in the top right. We didn't need to try again. So the machine learning approach for this particular example is an algorithm called Bayesian optimization. You don't need to know about the ins and outs of that. I'm just going to sketch how it behaves. And the big difference between Bayesian optimization versus a grid search is that you're building an internal model of what values you're going to expect before you run the experiment. So at the start, we're just going to expect that with a random lemonade, we expect someone might say, "Thank you very much, that was lovely," 40 times. And as we do our trials and we measure that in fact this lemonade is disgusting, we alter our perception. We change our model so that the region where we've just measured is expected to perform worse. So where do we try next? Well, we should try somewhere that we expect to perform better, up in the top right. And indeed we do. We got some better lemonade, we got more compliments, and so we adjust the region around it to reflect that expectation. And now we try somewhere slightly closer to the one we've just seen is good, to see if we can get even better. This one does in fact do that. So you can see that I haven't gone into the maths of how it works, that's not important, but you can see we've built a model that expects a high-performing lemonade up in the top right without exploring every possibility. It's gone straight there. And most of the trials added new information. They weren't completely useless. So at the end of all that, the point is we've arrived at a very good recipe for lemonade. And if we're talking about asking for donations, this would be maybe the best way to ask for donations. You might say, ask for £6 after the user's been on the site for 10 minutes. Those might be the parameters you were trying to optimize. Those were just made-up examples, so I'm going to talk a little bit through some real-world examples. First one is cookies. Google Brain did a fantastic experiment, not with lemonade, but with cookies, where the parameters were the different amounts of the different ingredients. Very similar setup. There's a few more parameters for cookies. We're talking flour, sugar, salt, butter, eggs, vanilla extract, lots of different ingredients. And so it takes a few more trials. We don't get there in 3 or 4. In fact, what Google did, they actually did this, was 90 successive batches of cookies. And in order to assess them, they'd send a little email out when we've cooked a fresh batch, come and taste it and leave your ratings. So they did this 90 times and arrived at the perfect cookie. A little media example now. So this is a paper from 2010 where they built a tool for animators. So in animation, it's often quite a hard problem to get your computer-generated graphics looking how you want them. There's a lot of parameters to optimize, and maybe they require a little bit of expert knowledge. It takes time. This tool allows an animator to just say, computer, suggest something to me. I'll tell you whether it's good or not. So it plays with the parameters. It shows a result. The animator can say, that was very good. Do more like that. Or, that's rubbish. Don't try something like that again. And so a bit quicker, you iterate through and get to an animation you're happy with. Something out of Facebook, maybe a little less exciting, but they were trying to optimize their CPU time. So get their algorithms working, or getting their backend rather, working as efficiently as possible. And so the parameters they were optimizing over here were compiler flags for virtual machine instances. And you can see they managed to improve fairly significantly. I don't know what that axis is, but it looks good. So that's all I've got to talk about in terms of machine learning. I'll just say a few words about who we are, just so you know I'm not just some person that's appeared out of nowhere. Datatonic is the company I'm from. We're a group of people with a range of backgrounds. Some of us have machine learning experience. Some of us are scientists, some of us are computer scientists, programmers, mathematicians. We've got a range of backgrounds. We collect all our expertise together, and we offer services in machine learning and data engineering to various clients. So here are some of the clients we've worked with within media. We do things like recommender engines. We've done A/B tests. We do dynamic pricing. And one thing to point out, if you want to see more of us, you can do so at a very soon opportunity, which is the 5th of April. We're doing a full day of training for people who want to know more about machine learning, specifically within media. So it's a full day. You bring along your laptop. It's a bit of a casual environment, not dissimilar to this. And there's hands-on exercises. You can register at that address. And please do talk to me, or I've got some colleagues over here as well after this session. And in the meantime, thank you very much.
Do we have any questions for Will? If you'd like to ask, I think to me that was one of the most clear and compelling explanations of how machine learning works. So it would be great to use the opportunity to ask Will if you'd like to know any more. Just put your hand up. Nigel has the microphone. Any takers? One here. Thank you. Ask away.
Hi, I'm just a director's assistant. I'm just interested in the future of technology and all that. So I'm very ignorant. I just wanted to know whether machine learning can be applied to things like de-risking investment or is that am I going too far ahead?
Sorry, I missed that.
Can machine learning and all that be used for helping de-risk a production investment?
De-risking?
Yeah, is that, am I
so
going
knowing
too far?
where to invest your money, what to commission, what to make.
Is this sort of technology helpful towards that?
Could you learn what is a successful kind of program to make?
The only answer I can give to that is if you can quantify it, then yes. So if you can express what you're looking for in terms of reduced risk as a number, that's the only thing machine learning can deal with, then yes, you can start to think about it in terms of a predictive task or an optimization task or a self-descriptive task.
Okay, great, thank you. And it's not happening yet, or it's not?
I think it is. I mean, in some cases, I think what you've described is the original famous Netflix example, where they weighed up the ingredients that makes a successful series, and of course they could measure that in terms of streaming. So I think it can be done, and I think people are starting to look at making the commissions more effective in that way and having fewer duds.
Okay, thank you so much.
Any more questions that we have? One over here.
While making the lemonade, you switch the probability from the lowest to the highest, but there may be cases where it may be somewhere in between. So do we keep iterating like so many times to get to there, or?
Sorry, again, I missed it. It's quite quiet.
On the preparation of lemonade, you gave the examples of starting from the lowest point,
Yeah.
and going to the best case at the top right. But there may be cases where it may be somewhere in between. So do we keep iterating for all those number of iterations, or I mean, how do you address those kind of situations?
So usually what we're talking about is we have some sort of criterion for stopping and saying our search is complete, which might be that you haven't found anything that improves on your best results so far in maybe 5 or 10 trials. So the way this particular algorithm works is it'll try something that it doesn't know much about, because it's looking to maximize the probability that you'll improve. So in areas where you don't know anything, there's a high probability that it could be better than what you've seen before. There's also a high probability it could be worse, but you're going to try it anyway. Whereas where you've explored and you know it to be bad, you're not going to try there again, because there's a very low probability of seeing something better. So yeah, to answer your question, it'll try whatever it doesn't know about, and then when it knows enough to say, I think I found the best answer, it'll stop.
One more question here.
Hi there. You mentioned it's getting quite good at dubbing. Can you explain a bit more about that, please?
Dubbing?
Yes.
Yeah, so this is a kind of a hot area of machine learning research, and the results are getting quite good. We're talking speech to speech. So speech to text has been around a long time, and that's, I wouldn't say anything like what a human can do, but in terms of speed, it might be. And text to speech is obviously a fairly solved problem as well. Speech to speech is a translation task that can be solved with very similar models, but it's only recently that people have been exploring exactly how. So it's essentially the same tech and the same people doing it, but recently there's been quite a few steps towards actually seeing good results with that.
Good. Anything final before we wrap up for the day? No, in that case, I would like to thank Will Fletcher from Datatonic. Thanks for a fantastic presentation.
Thank you, Rob.